In section 9.6, we are going to be discussing the quadratic formula and the discriminant. The quadratic formula is one additional way that we will be able to solve quadratic equations. Now, so far we have solved quadratic equations using four methods: graphing, factoring, completing the square, and taking the square root. For your warm-up today, I would like for you to solve the quadratic equation x squared plus 6x equals 7 by using each of the following methods. First, we will solve by graphing, then we will solve by factoring, and lastly, we will solve by completing the square. Okay, so let's begin by solving this quadratic by graphing. My first step is to write the quadratic equation in standard form. So I'm going to write this as x squared plus 6x minus 7 is equal to 0. Once I've written it in standard form, I can then graph it. Remember, our first step in graphing is to find the vertex, so we'll use the formula x equals negative b over 2a to find the x-coordinate of the vertex. So negative 6 divided by 2 times negative 1 would be negative 6 over negative 2, which is 3. So the x-coordinate of my vertex is a positive 3. I know then that the vertex occurs at the point 3 something. Now I have to find the y-coordinate of the vertex. So what I'm going to do is I'm graphing the related equation y equals x squared plus 6x minus 7. So I would recommend that you go to the calculators that you've been using and type this function into the calculator and then draw up a table. Once you get a table set up, you can look for a value of 3 in the table, and you can get the corresponding y value of the vertex from the table of your calculator. Another way to get this, of course, would be just to substitute 3 in for x into the function. And if you do that, the output that you're going to get is a negative 16. So the vertex is negative 3, negative 16. Well, I don't have on my axis over here 16 units to go down. So I'm going to use a scale of 2 when I graph this. So the first point would be negative 2, then negative 4, negative 6, negative 8, negative 10, 12, 14, 16. So the point negative 3, negative 16 would be about right there. And this is going to be my vertex. So 3, negative 16 is the vertex for my graph. Okay, now if you look at the equation, you can also very easily pick out, or look at the function rather, you can easily pick out the y-intercept. Hopefully you remember that the y-intercept is the c value of the graph, 0, negative 7. Another thing you could do is look in the table of your calculator, and wherever x is equal to 0, you're going to find it has a y value of negative 7. I'm going to go ahead and graph that point as well. So 0, negative 7 would be the y-intercept, and it's here. Now that's a little shortcut that I'm using because after I graph the y-intercept and I graph the axis of symmetry, which I'm going to go ahead and draw in here, I can then just reflect this point over the axis of symmetry, and notice that after I've done that, I should be able to get a nice graph of the quadratic. So it looks like it's coming up through here like so. That's the quickest and probably simplest way to graph a quadratic function. Now, I was asked to solve by graphing. So when I look at the graph, where do I find my solutions? Well, my solutions are wherever the graph crosses the y-axis, which is here, or not the y-axis, I'm sorry, the x-axis. So the x-intercepts are the solutions. So let's write that down. X-intercepts are solutions to the equation. So where does this function cross the x-axis? Well, as it turns out, this point here is negative 7, and this point is positive 1. So my two solutions are x equals -7 or x equals +1. Now normally we don't solve by graphing unless we have a graphing calculator, because graphing by hand takes a lot of time. So our next method of solving is probably the best way to solve this particular quadratic equation. Let's look at it. So next what I'm asking you to do is to solve by factoring. And again, I'm going to start the problem out in the same way that I started out the graphing problem. I'm going to rewrite this so that it's in standard form. X squared plus 6x minus 7 equals 0. But then, if I can, I'm going to factor the quadratic polynomial that's part of the equation. This quadratic will factor. X times x is x squared. And then I need two numbers that multiply to give me a -7, but are going to add to give me a +6. Well, since they're multiplying to give me a -7, that means one's positive and one's negative. And if I make the 7 positive and the 1 negative, those numbers do in fact add to give me a +6. Then I use the zero product property and I split these apart. X minus 1 equals 0 and x plus 7 equals 0. And then if I add 1 to both sides here, x is equal to 1. And if I subtract 7 from both sides here, x equals -7. So notice that I have the same solutions, or I get the same solutions when I factor as I did when I graphed. Okay, we have one more method that we're going to use to solve the quadratic. Remember that we should get the same solutions when we solve by completing the square. Using a different method to solve should not give us a different solution. We should get the same solutions. And again, whenever you're solving a quadratic, what you're going to want to do is put it into standard form. So x squared plus 6x minus 7 is equal to 0. Always my first step. But this is what we covered yesterday, because yesterday we were looking at, well, how do I take this and make it into a perfect square so that I can solve it? So remember, our first step was to rewrite the equation and leave an open space here and here. So we move the -7 to the right-hand side of the equation, and then we leave spaces so that we can add. Then we have to figure out, well, what number do I add? So I take the term in the middle, the b term, I divide it in half, which is 3, and I square that number, 9. And that tells me what number I should add to both sides of the equation. So what I have here is x squared plus 6x plus 9 is equal to 16. Then I rewrite this as a square. And remember, I told you yesterday that your variable is x. We take the sign here from the center. We take the number that we used here before we squared it. And that's how we change the form of x squared plus 6x plus 9 into a binomial that's being squared. Now the reason I want to do this is so that I can take the square root of both sides. And the square root of the quantity x plus 3 squared is just x plus 3. And the square root of 16 is plus or minus 4. Now I'm going to split these into two solutions. X plus 3 is equal to 4, and x plus 3 is equal to -4. And I'm going to solve. If I subtract 3 from both sides, I get x equals 1. And if I subtract 3 from both sides here, I get x equals -7. Notice again that I have the same solutions, even though I solved it in a different way. So remember that we've been solving quadratic equations by various methods. And so far we have solved by graphing, factoring, taking a square root, and by completing the square. So next what we're going to do is what our lesson is about for today, which is solve a quadratic equation by using what is known as the quadratic formula. So your learning target today is I can solve quadratic equations by using the quadratic formula. The quadratic formula is a very famous formula, and it's a formula that you're going to want to memorize. Because we use it so much in mathematics, it's just a lot easier if we have the formula memorized. In addition to solving quadratic equations by using the quadratic formula, a second learning target that we're going to have today is that we are going to find the number of solutions of a quadratic equation. To do this, we're going to use something called the discriminant of the quadratic equation. So in just a minute, I'll show you what the discriminant is and explain it to you a little bit more thoroughly. Okay, so the key ideas for this particular section, there's two of them. The first key idea is that any quadratic equation can be solved using the quadratic formula. Okay, now, don't panic when you see this formula for the very first time. You can look at it and say, oh, that's too confusing, but it's really not that bad once we break it apart, and that's part of what we'll be doing today is breaking it apart. So here's the formula. X is equal to negative b plus or minus the square root of b squared minus 4ac, and all of this is over 2a. That's the formula. But again, don't worry, I'm going to show you how we use it, and it's really not that bad. So your first key idea is any quadratic equation can be solved by using the quadratic formula. The second key idea is that the discriminant of a quadratic equation can be used to determine the number of solutions an equation has. Well, when you're looking at the formula, the discriminant is the part of the formula that's underneath the square root sign. It's this part right here. It's the b squared minus 4ac. It's a very special piece of the formula, and we use it to determine the number of solutions that a given quadratic equation has. Now, keep in mind that this formula is only used for quadratics. That's why we call it the quadratic formula. Okay, so here's your first key concept then. The first key concept introduces the idea of the quadratic formula. So notice that in the statement it says, if ax squared plus bx plus c equals 0, and a does not equal 0, then, and then it gives you this right here, this is the quadratic formula. X is equal to, let me write that first and then I'll read it to you. X is equal to negative b plus or minus the square root of b squared minus 4ac, and all of that is over 2a. So this is the formula. So put a star by it. You have to memorize that. You will have to know it for your test, and I'm not going to give it to you on the test because you have to have this memorized. So go ahead and start trying to learn it. Okay, now, when you're looking at the quadratic formula, you have to first designate what these values of a, b, and c are. So think about this particular quadratic equation. Notice that it's written in standard form. And remember, I've taught you that anytime you're solving a quadratic, always put it in standard form first. Once it's in standard form, you can designate values of a, b, and c. In this particular quadratic equation, a equals 2. It's this number here. Okay? B equals 3. It's this number right here. And C is equal to negative 5. It's this number here. And notice how I use the sign, that little negative sign here is part of the value. So if you have a negative sign if you have a minus sign rather in the quadratic equation, make sure that you include that sign in your values of a, b, and c. Now notice what they've done here is they've just taken those values and plugged them into the formula. And then after they plug them in, then you just simplify that. And what's great is you've got a great calculator that you can use to help you simplify things, so hopefully it won't be too terribly difficult for you. Okay, so your first key concept is the quadratic formula itself, what it is and how we use it. Okay, so here's your second key concept. The second key concept is the discriminant. Now remember what I told you earlier. The discriminant is the part of the quadratic formula that's underneath the square root sign. So let me write the formula up here at the top again for you so you can see this a little better. So it's x equals negative b plus or minus the square root of b squared minus 4ac, and all of that is over 2 times a. Okay, now look underneath the square root sign at this. That's the discriminant. Now the discriminant basically helps us to determine how many solutions we have. And this chart can be a really big help to you as you're learning to use it to solve these problems. If you look at it, what it's saying is this. If the discriminant is positive, because greater than 0 means positive, that tells us that there are 2 real number solutions. If the discriminant is equal to 0, that is, it's neither positive nor negative, it is flat out 0, that tells us that there is 1 real number solution. And if the discriminant is negative, that is, that it's less than 0, that tells us that there are no real solutions. Okay, so this might not make that much sense to you, but it will in a minute after we've worked some problems. I do want you to notice that for each of these, this chart gives you an example of how to use the discriminant. So notice here, if x squared minus 6x plus 7 is equal to 0, as is the case of this quadratic, the discriminant is found by taking b squared minus 4ac. So the value of b in that case is negative 6, because it's the linear term, it's that middle term. The value of a is the first number here. It's a 1, because if there's not a coefficient, you use a coefficient of 1 for any term. And c is 7 in this, so it's this number here. So notice that they just plugged those numbers into the discriminant formula, and they got back a value of 8. Now, because 8 is positive, that tells me that I have 2 real solutions. If the number that had come back was 0, as in the case of the second example, that tells me that I only have 1 real solution. And if that value had come back as negative, as in the third example, that tells me there are no real solutions for the quadratic equation. And we've kind of talked about this before, that the solutions graphically are represented by the x-intercepts. So 2 real solutions means that the graph of the function crosses the x-axis 2 times, like this one. 1 real solution means that the graph of the function touches the x-axis in one place. No real solutions means that the graph of the function never intersects the x-axis. It's either completely above or completely below the x-axis. Okay, so let's look at some example problems. Okay, for example 1, we're going to be finding the discriminant of a quadratic equation. So notice that the question that's being asked here is how many real number solutions does each of the following quadratic equations have? So the next couple of slides are going to take you problem by problem. Now, I've given you the chart on each of these slides just to help you remember that we're going to use the chart to refer back to make sure that we can know exactly what we're looking at when we get our discriminant. Okay, first part. First and foremost, always, place the equation in standard form before you ever start using the discriminant or the quadratic formula. So we're going to write this in standard form. So x squared, I'm going to take the negative 5x, move it to the left-hand side of the equation as positive 5x. Then I've got a negative 13 is equal to 0. So I'm writing the quadratic formula in standard form. Okay, next step. Not the quadratic formula, I'm sorry. I'm writing the quadratic equation in standard form. Next step. Go ahead and designate your values of a, b, and c. Like so. Remember that we're going to be using those for the discriminant. We're also going to use it for the formula at large. Now keep in mind, the formula is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. The discriminant is this section here under the square root sign. Since I'm asked to find out how many real number solutions does the following quadratic equation have, I'm just going to plug in for the discriminant and then use my chart here to help me make a decision. So b squared minus 4ac is the discriminant. I'm going to say that 5 squared minus 4 times 1 times negative 13. So notice that I'm just putting the numbers in, and that is 25. Now this is where you have to be careful. I'm subtracting 4 times 1 times negative 13. So 4 times 1 is 4, and 4 times negative 13 is negative 52. So when you're looking at these negatives, be very careful. Since there's a negative here and a negative here, those two negatives are going to make a positive. And my actual discriminant is going to be found by taking 25 and adding 52 to it, which is 77. So my discriminant is 77. That's positive. And that's what I'm looking for. Is the discriminant positive? Is it 0? Or is it negative? Because if the only question I want to answer is how many solutions does it have, then I just need to decide, is the discriminant positive, 0, or negative? Since the discriminant is positive, that tells me that I'm in this section of the chart right here. And there are 2 real number solutions. So I'm answering the question that was asked of me up here. How many real number solutions does each quadratic equation have? This particular quadratic equation has 2 real number solutions. Okay, let's try another one. Okay, next one. How many real number solutions does each of the following quadratic equations have? We're on part B here of example 1. So again, I'm going to use the discriminant. The discriminant is b squared minus 4ac. So first, I check my equation, make sure that it's in standard form, which it is. Then I designate my values of a, b, and c. Okay. After that, I plug in those values into the quadratic equation. So b is 10. So 10 squared minus 4 times a is 1 times 25. Well, 10 squared is 100, and I'm subtracting. 4 times 1 is 4, and 4 times 25 is also 100. So I have 100 minus 100, which is 0. So I look at my chart and I say, well, what happens if the discriminant is equal to 0? That means I fall into this middle category. And according to the chart, if the discriminant is equal to 0, that tells me that there is 1 real number solution. Now, I wasn't asked to figure out what that solution was. I was just asked to determine how many solutions there are. So since that's the question that I was asked, I'm able to answer it just by looking at the discriminant. Okay, let's try another one. Next up. How many real number solutions does this quadratic equation have? Again, I'm going to use the discriminant. So b squared minus 4ac. Designate the values of a, b, and c. Once you designate the values, then plug in negative 2 squared minus 4 times negative 5 times negative 14. Now I'm going to give you a little shortcut trick here for these negative signs. It's going to help you out a lot. Negative 2 squared is 4. Now when you count your negative signs here, see how I have a negative here, and a negative here, and I'm multiplying? That is 3 negative signs. That's an odd number of negative signs. And if you have an odd number, that means that you're going to end up subtracting. So this is going to be 4 minus 4 times 5 times negative 14. Well, 4 times 5 is 20, and 20 times negative 14 is 280. Now, the other thing that you can do if you're not that great with positives and negatives is you can plug that into a calculator and get your answer from the calculator. So 4 minus 280 is negative 276. And since the discriminant is negative, we're in this category here. The discriminant is negative. That tells me that there are no real number solutions. Okay, let's move on. And the next thing that we're going to do is we're going to talk about using the quadratic formula itself. So now we're going to actually solve some equations, quadratic equations using the formula. So here's the formula again. The formula is x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. So what I'm going to advise you to do is when you're using the formula is to find the different parts of the formula first and then plug them in. Okay, now what I mean by that is let's go ahead and designate our values of a, b, and c. So a is equal to 3, b is equal to 1 because the coefficient in the middle term is a 1, and c is equal to negative 4. Okay, now after I've designated it, I'm going to write down each of the 3 parts of the formula. So the first part is negative b, the second part here is the discriminant, b squared minus 4ac, and the third part is the 2a. So let's write down what each of those parts would be. So negative b is going to be equal to negative 1. I just take the b term and make it negative. B squared minus 4ac is going to be 1 squared minus 4 times 3 times negative 4. Now I'm going to go ahead and figure that out. So that's going to be 1 plus 4 times 3 is 12, and 12 times 4 is 48. So 1 plus 48. So that's going to be 49. So this is part 1. This is the second part. My third part to the formula is 2a. 2a is going to be 2 times 3, which is 6. So notice that now I know that negative b is a negative 1, the discriminant is 49, and 2 times a is 6. And I can just plug those into the formula. So negative b is negative 1, plus or minus. The square root of b squared minus 4ac is 49, and 2a is 6. Okay, now remember that whenever you solve a quadratic equation, you're going to come out with this plus or minus situation, which splits your answers into 2 parts. So here I have negative 1 plus 7 divided by 6, and negative 1 minus 7 divided by 6. Now, for those of you who are saying, where did that 7 come from? Well, if I take the square root of 49, the square root of 49 is 7. So that's where the 7 came from. Okay, now, we just have to figure out what each of these are. So, negative 1 plus 7 is 6. So that's 6 over 6, which is 1. So my first solution is the 1. And then negative 1 minus 7 is negative 8. And negative 8 over 6, which is negative 4 over 3. Or if you typed it into your calculator, it would be 1.3 repeating, is my second solution. So I have 2 solutions. 1 or negative 4 over 3 is what x is equal to. Now, it's really not x. Did you notice that? Really, the variable that was up here was a z. So instead of writing x right here, I'm going to replace that with a z. And I'm going to say that z is equal to 1 or z is equal to negative 4/3. Okay, let's try another one. What are the solutions of the equation r squared plus 6r plus 9? So again, I'm going to write the formula. And the formula is x equals negative b plus or minus the square root of b squared minus 4ac. All of that's over 2a. I'm going to designate my values of a, b, and c. So a is equal to 1, because there's a 1 right there. B is equal to 6. C is equal to 9. I like to find, then, each of my three parts. So I want to know, well, what is negative b? Well, negative b is negative 6. And then I want to know, well, what is b squared minus 4ac, my discriminant? B squared minus 4ac is going to be 6 squared minus 4 times 1 times 9, which is 36 minus 36, which is 0. And then I would like to know, well, what is 2 times a? Well, 2 times a is 2 times 1, which is 2. So now I've got each of the three parts of the formula, and I can just plug them in. Now, look at the discriminant really closely. It's this value here, the 0. What does that tell me is going to happen? Well, that tells me that I'm only going to have one solution to this quadratic. So I want you to watch when we plug this into the formula why you only get back one solution to the quadratic. Okay, so here it is. If I put this into the formula, I would have x is equal to, now, negative 6 is my negative b, plus or minus the square root of, my discriminant is 0, and 2 times a is 2. Now remember we split those, so negative 6 plus 0 over 2, and negative 6 minus 0 over 2. Now remember that where I'm getting that 0 from here is that the square root of 0 is 0. Okay, so the square root of 0 is, in fact, 0. Okay, so negative 6 plus 0 is negative 6, so that's negative 6 over 2, which is negative 3. And over here, negative 6 minus 0 is negative 6. So negative 6 over 2 is negative 3. So see how I get the exact same solution? So that's why I don't need to write the word or there because I just have one solution. I was about to, though. That's why my solution is one number. It's just the negative 3. Now notice that I was actually solving for an r. So I'm going to write this as r is equal to negative 3. And that's my solution. Okay, let's try one more. What are the solutions of the equation h squared plus 2h equals negative 4? Now remember what your first step always is. Whenever you're solving quadratics, you want to start by writing it in standard form. So I'm going to go ahead and write this as h squared plus 2h plus 4 is equal to 0. Now for this one, I'm again going to, I usually write the formula out first, and the reason I'm doing that is because the more I write it, the more I'm likely to remember it later. So I would advise you to write the formula out every single time you use it, and make sure that you start to memorize it. I'm going to designate my values of a, b, and c, so I know what numbers I'm putting into my formula. So a is equal to 1, because this coefficient here is a 1. B is equal to 2. C is equal to 4. Okay, let's figure out each of our three parts so that we know what numbers to put into the formula. Negative b would be negative 2. B squared minus 4ac is going to be equal to 2 squared minus 4 times 1 times 4, which is going to be 4 minus 16, which is negative 12. Oh, well, notice what happened. When I did my discriminant and found my discriminant turned out to be negative. Well, what does that mean? Well, remember from our chart that if the discriminant is negative, that means that this particular quadratic has no real solution. And so that means that there are none here. So I can stop my work right now, write down that there's no real solutions, and I'm done. Again, the discriminant is used to help us to determine what type of solutions that we have and the number of solutions that we have, so that if we don't have any real solutions, we can just stop because there's no need to continue. Okay, so let's look at how we might apply this to a word problem. So the problem states your school wants to take out an ad in the paper congratulating the basketball team on a successful season, as shown at right. So the area of the photo will be half. It's actually not at right because I had to split this when I copied it, so it's actually this diagram down here at bottom. The area of the photo will be half the area of the entire ad. How wide would the border be? Okay, so keep in mind that this is the photo, what I'm highlighting in green, and this right here is the border. Okay, so we're asked to, in the first section of thinking about this problem, we're asked to just read the problem and study the diagram and make sure that we understand it. So hopefully you see from the photo and the border that we have a photo, and that photo here is being surrounded by a border, but the border is only on the top portion of the photo and the side portion. So the border is not surrounding the entire photo, it's just surrounding two sides of the photo. Okay? Now, I also want you to make note of this statement here because this is really important. The area of the photo will be half the area of the entire ad. That's very important. And what they're asking us is how wide will the border be? So notice that they've designated X here to be the width of the border. Okay, so let's look at how this particular problem we can go about. Okay, first of all, let's think about what we know. So again, our diagram was a photo that's 5 by 7 with a border that surrounds it on two sides, like so. Okay. And that looks more like a square, but I think you'll be okay with that. Actually, let's do this just to make it look a little bit better. We'll enlarge it this way because I want to make sure that you see this. There we go. This is 5, this is 7, and we've got a border going around it like this. Now, the width of the border is designated as X. Okay. What are the dimensions of the photo and the ad? So that's the first question that they're asking us here. And what they're trying to do is trying to help us to understand what we know. So we do know something about the dimensions. So if I'm just looking at the photo, now I'm going to color the photo in green. What are the dimensions of the photo? Well, the photo has dimensions of 5 by 7. Okay. Now what they want to know is what is the dimensions of the entire ad. Okay, so if you look at the ad is this entire area here. It's going to cover this area. So what is the length and width of the ad? Well, the entire ad, we're going to take the photo length and add X to it, and take the photo width and add X to that, and that's going to give us the dimensions. So the ad has dimensions of 5 plus X times 7 plus X. Okay. Now, they're telling us to let W here be the width of the photo and L be the length of the photo. So if you were going to look at this in terms of area, what they're basically saying is area is length times width, and we're going to be using this formula to help us. Okay. The other thing that we could do is we could say, well, this is the width and this is the length, W and L. Okay, let's keep going. Again, what we're doing is we're just trying to dissect the problem. Now we want to know, well, what do you need to solve the problem? So we need a quadratic equation that we can write that best describes the relationship between the area of the photo and the area of the ad. So we kind of have to think about this from the original problem. So this was 7, this was 5, And then I had a border around here that was x, y. That's a little bit better than the last diagram I drew. This is x, this is x. And we said, well, the length here is 7 plus x. And then we said that the width is 5 plus x. And we know that we're talking area, and area is length by width. So the area of the ad is 7 plus x times 5 plus x. So that's the area of the ad. But the problem that we've got is they didn't outright tell us in the problem what the area of the entire ad is. But they did give us a hint, because they told us that the photo is half the area of the ad. Okay, well, if the photo is half the area of the ad, well, can we figure out the area of the ad? Well, sure we can. If you look at the photo, what is the area of the photo? It's a 7 by 5 photo. Well, area is length times width, so this entire area is 35 square inches. So this area of the photo is 35 square inches. And if the photo is half the area of the ad, that means that the area of the ad is twice the area of the photo. That means that the area of the ad would have to be 35 plus 35, or 35 times 2, which is 70 square inches. And that is very important to us because we can use that to set up our equation that we can use to solve the problem. Okay, so that's the next step of solving. Using the quadratic formula, how will you be able to solve for x, the width of the border? Well, our equation is 70 is equal to 5 plus x times 7 plus x. And we need to write this equation in standard form and then use the quadratic formula to solve. Okay, so first, to write this in standard form, what we're going to do is we're going to multiply the binomial. So I'm going to start over here. 70 is equal to 35 plus, the outside terms will be 5 times x, inside terms is 7 times x, and x squared. Okay, next I'm going to add these two middle terms together and get 70 is equal to 35 plus 12x plus x squared. Okay. Now remember, I'm wanting to put it in standard form, so that means I need 0 on one side. So let's go ahead and take this part here and write those in standard form. Write it as x squared plus 12x plus 35 is equal to 70. And then let's swap these around and write x squared plus, that should be an x, 12x plus 35 is equal to 70. Now, if I subtract 70 from both sides, that would put it in standard form. So I have to kind of rearrange things to get it into standard form, like so. Okay, now remember you're using the quadratic formula. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac. Oops, let's get that over. And that's over 2a. So let's designate our values of a, b, and c to put into the formula. So a is 1, b is 12, c is negative 35. Okay? Now again, what I like to do is find all three parts of the quadratic formula and then put them in. So negative b would be a negative 12. b squared minus 4ac is going to be 12 squared minus 4 times 1 times negative 35. And if you plug that into your calculator, you should get 284. And then 2 times a is going to be 2 times 1, which is 2. So what I've got here is I've got my negative b, my discriminant, and my 2a. So let's plug it into the formula. So x equals, negative b would be negative 12, plus or minus the square root of 284, and that's over 2. Now let's get two solutions. Go ahead and change that square root of 284 to a decimal when you split these up. So negative 12 plus, the decimal value for the square root of 284 is 16.9 over 2. And my second one would be x is equal to negative 12 minus 16.9 over 2. Okay, now, two solutions. Again, we put these into our calculators. So if you take negative 12 plus 16.9, that is 4.9. And we would take 4.9 and divide it by 2. And this one would give us x is equal to 2.4, which actually makes a lot of sense to this problem. Over here, our answer would turn out to be negative 14.45. So again, I take negative 12, I subtract 16.9, I get that answer, and then divide it by 2. By the way, if you are using a calculator and you typed these in, make sure that you put parentheses around that before you divide by 2. So if you're not getting the correct answer when you're using your calculator, then the reason why is because you're not dividing it out correctly. Okay? Okay, so the width of the border is about 2.4 inches. Because this answer is negative, we have to rule it out because we can't have a negative width, which means this is our answer. So let's write that as a complete statement. So I'll put it up here. The width of the border is 2.4. Okay. That you might have, which is just finding approximate solutions. So these are pretty easy problems actually, and I'm just going to show you how to do this on a graph so that you can get the answer off of a graph. So a football is passed through the air and caught at ground level for a touchdown. The height h of the ball is given in feet is given by h equals negative d squared plus 12d plus 6, where d is the distance in feet the ball travels horizontally. How far from the player passing the ball will the ball be caught? Okay, so what I'm going to do is I'm just going to kind of graph this out. And when I graph this, you'll be able to actually see the ball going. So remember that to graph this, we're going to first do, well, here's our equation, our function rather, negative d squared plus 12d plus 6. So negative b over 2a would give us our vertex. So that's negative 12 over 2 times negative 1, and that's 6. Okay, so our vertex is found at 6. So 1, 2, 3, 4, 5, 6. So that's where the axis of symmetry is going to be. So I'm going to go ahead and draw in my axis of symmetry right here at x equals 6. And the vertex is going to lie along that line. So let's figure out where that vertex is. So you could plug this into your table function in your calculator if you want to, or you can just plug it into the function here. But let's go ahead and figure out where is the vertex. So the vertex, if I plug in a 6, I would get negative 6 squared, so that's negative 36, plus 12 times 6, well that's 72. Which is positive 36. Positive 36 plus 6 is 42. So you should get back to 42. So what that means is that the ball is going up 42 feet. So I'm going to use a scale of 6 on this axis. So 6, then 12, 18, 24, 30, 36. So here's 36, and then 42. So the ball goes all the way up 42 feet in the air. So I want you to picture, I know all of you hopefully have been to a football game or you've watched a football game. And so I want you to kind of picture that this is the ball. Now where does the ball start? It starts 6 feet off the ground. That's the y-intercept right here. So the ball goes up So there goes the football. And the football comes back down. Now, you've got to kind of assume that the player is 6 feet off the ground. He's throwing the ball, right? So the player who catches the ball is probably standing over here, and he also is about 6 feet off the ground. So he catches it about right there. And the question, remember, we're finding approximate solutions. So the question says, well, how far from the player passing the ball will the ball be caught? And according to this equation, this D right here, which is our x-axis, is distance. It's the distance that the ball travels horizontally. So when you're looking at this, how far is that ball traveling horizontally? Vertically, it's going up this distance. So that's vertical. But how far is the ball traveling horizontally? Do you see it? Well, if you count your numbers down here, 1, this is 6. Right here, that's a 6. So 7, 8, 9, 10, 11, 12. Remember that the axis of symmetry divides this into 2 equal halves. So if from here to here is 6 feet, that means that from here to here is another 6 feet. And the ball is going to be traveling 12 feet. So it's a 12-foot throw, basically, is what's happening. So how far from the player passing the ball will the ball be caught? The player will catch the ball. So we'll catch the ball. Let's go ahead and erase this. After it has gone 12 feet. It's gone horizontally 12 feet. Because it's not vertical, it's just horizontal. Now, when I come back, and we have some time, I'm going to show you how to use the quadratic formula to solve this problem as well. Okay? Okay, so let's try to wrap this up and think this through. We have covered now 5 methods of solving quadratics. And so I want you to think about each method and think about when you would use each method, because each method is used at a certain point in time. So method number 1 is, or one of the methods is completing the square. You're going to use completing the square if the coefficient of your x squared term is 1, but you cannot easily factor. So an example of an equation that would have that would be something like this. X squared plus 12x plus 6 is equal to 0. Another thing that I like to look for to use the completing the square is to look at this middle term right here. And if it's an even number, that means I can divide it by 2 fairly easily. That's a great time to use completing the square. But notice that this equation here cannot be factored. And the reason it can't be factored is because there are not 2 numbers that multiply to give me 6, but add to give me 12. Now, you should use factoring if you can easily factor the quadratic equation. So that would be something like this. X squared plus 6x plus 8. So can you give me 2 numbers that multiply to give you 8 but add to give you 6? Well, sure I can. This would easily factor into x plus 4, x plus 2. Because notice that 4 times 2 is 8, but 4 plus 2 is 6. So that one's easily factored. That's when I want to use factoring. Now, graphing is a little tougher for us because we're not using graphing calculators yet, but eventually you will be using graphing calculators. So the best time to solve by graphing is when you have, so let's write it this way. Use graphing when you have a graphing calculator. that is a great time to use graphing because you can use the calculator to graph and then you can read the solutions off the graph that the calculator gives you. By the way, there's a lot of online tools that will also graph a quadratic function. So you don't just have to have a graphing calculator. You could have any sort of graphing device. Okay. Now, the quadratic formula, to me, the quadratic formula is your catch-all. Anytime you can't think of the way to solve a quadratic equation, you can always use the formula. So use the quadratic formula. Oh, that should say if. So let's change that right quick. If the equation cannot be easily factored and completing the square is too difficult. So let's say that we had something like x squared plus 2.5x. So let's see, we have a decimal minus 3.7 is equal to 0. If I had something like that, I would definitely want to use the quadratic formula. Now, a lot of people will use the quadratic formula and never use completing the square. I'm not necessarily going to agree with that because if you know what you're doing, completing the square is actually faster, especially if you have very nice, easy numbers in your quadratic to work with. Now, lastly, we've learned how to solve by using square root, but you can only use this in one case, and here's the case. So you want to take a square root when b is equal to 0. So take a square root when b is equal to 0. So notice here in this equation that you've been given that you don't have a b term. Well, that's because b is equal to 0, and that eliminates that middle term. If you don't have that middle term, that's when you're going to want to use this particular method, solving by square roots. Okay, so I hope that you've been able to understand using the discriminant and the quadratic formula. Don't worry, if we need to go back over some of this information, you guys know that I'm around and will help you as much as I can. Just let me know how you're doing.